Alright, hello. So we are going to continue with our discussion of Chapter 4, looking at forces in one dimension, and we're going to discuss the last section of this chapter, which involves interaction forces. And so first let's talk about what are interaction forces and how to identify them. So these are forces that always come in pairs. And so let's say that you and a friend are on roller skates. Okay, and you push your friend forward, and when you do that, you roll backward, and that's due to interaction forces. So you exert a force on your friend, and your friend then exerts a force on you. And so this is what's called an interaction pair. These are two forces that are in opposite directions, and they have equal magnitude, and they're acting on two different objects. And so this is also known as an action-reaction pair. And so this relates to Newton's third law, which we're going to talk about in a second, which is basically that for every action, there's an equal and opposite reaction. One force does not cause the other. They must exist together or not at all. So that's why they're called a pair. You can't have one without the other. Okay, so Newton's third law basically says that all forces come in pairs. And these two forces that are in the pair act on different objects, just like you acting on your friend and then your friend acting on you. And they are equal in strength and opposite in direction. And so we would write this as the force of A on B is equal to the negative force of B on A. So different objects, equal in strength, opposite in direction. That's why one is positive and one is negative. So let's look at another example. So Earth pushes on you. This is the force due to gravity, which is your weight. And then because we know forces exist in pairs, because Earth is pushing on you, you also must be pushing on Earth. And we know that applying a force causes acceleration. And so you applying a force on the Earth causes Earth to accelerate. Well, if Earth accelerates when you push on it, then why isn't Earth spinning out of control? I mean, there's all these people on Earth. Okay, well, the reason for that is because the other factor involved here is mass. Your mass is so much smaller than that of Earth that the force, this interaction pair of forces, is going to be really small. And so it's not noticed by Earth. Okay, another example of this is when you're driving in your car and a bug hits your windshield. Well, your car exerts a force on the bug, and the bug exerts a force on the car, and they're equal and opposite in magnitude. But because of the mass difference, that force felt by the bug has a much larger effect on it than the same magnitude of force felt by the vehicle. And so that's why usually when a bug hits your windshield, it gets smashed completely because of that difference in mass. The force is the same, but the mass is not, and that has an effect. Okay, so some other forces we can talk about are specifically of ropes and strings. And there's a specific name for this type of force, and it's called tension. So tension is the specific name for the force exerted by a string or rope. We assume all strings and ropes are massless, so they're not contributing to the mass of the object. We would just look at the object. Okay, so an example of this, if we have tug of war, two teams pulling on a rope, we want to know what's the tension. Well, each side is pulling with a force of 500 newtons. But the tension does not equal 1,000 newtons. Number one, they're pulling in opposite directions. And so we divide the rope in half and we look at each side, and each side is pulling with 500 newtons, and so that's equal to the tension on the rope. Another force we can talk about is what's called the normal force, and this is the interaction pair to gravity. So it's the perpendicular contact force exerted by a surface on an object. And so we have an object, and let's say it's sitting on the ground, and we know gravity is acting downward on it. Well, our normal force is perpendicular to the contact force, so contact force is the surface. Perpendicular would be opposite of that, okay? And it's exerted by a surface, so it's going up, and this is called F sub n, which is the normal force. So don't get that n confused with newtons, which is a unit. It's always perpendicular to the plane of contact between two objects. And it's always equal to the weight of the object. So in this case, it's equal to the force due to gravity. Now, next chapter, when we talk about motion in two dimensions, that won't always be true. Okay, so here's the homework that we're going to work on. We will also discuss the notes and go over some examples. Have a good day.